Whenever I explain a confusion matrix, I jokingly say that a confusion matrix tells you how confused your model is. That is somewhat true because the confusion matrix evaluates the accuracy of your model. However, the confusion matrix is not a metric. It's a table that shows a summary of the prediction results for a classification model. The number of incorrect and correct predictions is summarized with count values and broken down by each class. This is an important tool that gives insight into the types of errors being made by your model. You'll notice the confusion matrix is a 2x2 matrix that shows 4 possible outcomes: true positive, false positive, false negative, and true negative. In a real confusion matrix, the count of each outcome appears in a box. If you recall, a true positive is where the model correctly predicts the positive class or true value. Similarly, a true negative is where the model correctly predicts the negative class or the false value. A false positive is where the model incorrectly predicts the positive class, and a false negative is where the model incorrectly predicts the negative class. These values help you determine metrics we've discussed before, like accuracy, precision, recall, and F1 score. Let's review the Python code to produce a confusion matrix for our public safety crime prediction model. Here is the confusion matrix. The output shows the true positives at 0, 0, the false positives at 0, 1, the false negatives at 1, 0, and the true negatives at 1, 1. Here, the true positive is 51,492, the true negative 102,583, the false positives 64,021, and the false negatives 33,720. A visual representation of the confusion matrix is also helpful. Here is the code that we can use to display a visual representation. Makes it much easier to understand. Well, how do you interpret these results? We'll use these values to calculate accuracy, recall, precision, and the F1 score. The scikit-learn library also calculates these metrics for you using the classification report function. After we run the predictions, you'll see the metrics down here for precision, recall, F1 score, and accuracy. Accuracy ends up being 61%. Precision ends up being 45%. Recall ends up being 60%. And F1 score ends up being 51%. While our example only shows 2 class values, true or false, a confusion matrix can easily be applied to problems with 3 or more class values by adding more rows and columns to the confusion matrix. Now that you understand the confusion matrix and how it's used to understand the accuracy of classification models, let's look at metrics used to evaluate regression models.